So the title of this talk is based on a book chapter I wrote at this point more than a year ago with my former colleague Kush Varshini at IBM Research. I used to work at IBM. So we did a selected overview of both our own work and broader HCI work that study this topic of explainable AI and take human-centered approaches, meaning focusing on people's needs, interactions with AI explanation. At that time, it was also for me to reflect on this question of what can human-centered approaches do for explainable AI, and use as a lens to also reflect on how the HCI and AI community can better work together. I'm sure that's a question that you all here reflect on a lot, so I really appreciate the opportunity to speak here and hopefully having conversations with all of you. I also realized my answer to this question has also been driving my own work. So today I will also share some of our very recent work. It's also the first time I talk about them, so please bear with me. I want to start with the definition, right? What does explainability mean? If you work in the field, you have probably seen a lot of this kind of discussion, also related term like interpretability, transparency. But I'm going to take a broader and simple definition that also really highlights this human-centered nature of this topic. That is, explainability is about making AI understandable by people. With that, my focus is often on this AI system people interact with rather than model per se. And also not just about explaining AI decision process, because people are interested in broad range of information, how the model was developed, what's limitation, and obviously not just algorithm and technique. And today I'm going to focus more on the interaction, the design side of things. I think I don't need to convince you that explainable AI is a hot topic, right? Even in popular news. It's also in the regulation. For example, the GDPR law in Europe state that whenever you have automated decision process, people have rights to meaningful explanation. Explainability is also considered as a principle or a pillar of responsible AI, which is about developing AI technology that are ethical, minimize harms to individual and society. And I'd like to see explainability as the enabler or foundation for many other principles of our AI, right? Because again, explainability is about understanding, and understanding allows for human scrutinization and, if necessary, intervention. And with that, we can have better model, ensure safety, fairness, and help end user to have better usability, appropriate trust, and also have oversight for things like privacy, accountability, and things. So where my own work and this HCI work situated is also a world where the technical AI community has made prior strength. So there has already been a vast collection of XAI algorithms developed. So this is not the focus of this talk, but I want to give kind of 1 minute overview. Want to highlight that these many algorithms, hundreds if not more, also take various forms, even if we disregard the many different computational properties, right? So there are directly explainable model, some people call glass box model, that follow this relatively human understandable intuitive process, right? Things like a decision tree, rule-based model, linear regression. There are also lots of algorithms producing post hoc explainability. That is when you already use this kind of black box model, say deep neural network or large ensemble, that they don't really follow human intuitive process. And you will need another set of algorithms to generate explanation. And there can be global explanation, for example, using a simpler model to approximate this black box model's logic. You can also explain a particular prediction or decision called local explanation. A very popular explanation is feature importance. Essentially highlights for this instance, this input, which feature is important, contribute to the final decision. There are also counterfactual explanation that answer this why not a different prediction. For example, if you change this feature, you'll get a different prediction. This is because people are often interested in a different, often more desirable outcome. Another notable trend here is also there have been lots of XAI toolkits developed in the industry. So these are open source toolkits. People can plug in their own model data, then they can leverage this state-of-the-art algorithms. So in fact, what got me into this topic was in 2019, when I was working on IBM, I started working on this toolkit called AI Explainability 360. And Microsoft has a version called Interpret ML. So with all these toolkits lowering the barrier, right, I think we're really kind of on the verge of going to see more and more real-world AI system that has explanation component. And I like to view this human-centered research also as bridging work, right? Bridge this algorithmic capability to having real-world XAI system, effective system, right? So this system will work in many domains, serve many different users. And very importantly, they're going to be built by practitioners, right? Data scientists, developer, designers. I think it's helpful to also take a step back, right, to see these technical works as producing a toolbox for practitioners. While there are incredibly interesting technical challenge for practitioner at the end of the day, right, what they need is a good, reliable toolbox and also know how to use it. So with that metaphor of a toolbox, right, I summarize these three kinds of contribution that this HCI work make. Of course, there are far more than 3 HCI contribution, but simply a way for me to cluster some emerging work. The first one is to navigate this toolbox, right, to inform technical choices by people's explainability needs. And second one is to assess the toolbox, especially to uncover pitfalls of existing methods through empirical studies. And with that, we can expand the toolbox, right, inform new method, conceptual framework for more human-compatible explanation. So I will start from the first one, how to navigate this toolbox. One place to start is to have this kind of top-down characterization of this space of people's explainability needs. Then we can make design recommendations accordingly. So I think the field has always recognized that there are many different stakeholders who need explanation. So many early work try to answer this question of who are the prototypical users of XAI. One group that many early work focus on are the model developers who may want explanation to investigate, verify the model, and debug the model. In HCI as well, there are lots of system work in HCI with community on this kind of explanatory debugging tool. More recently, I think much focus is on AI decision support system, where the direct users are decision maker, right? So this is a real-world example of this kind of loan risk assessment AI that can help a loan officer to make loan decisions. There are many problems, issues with this kind of system I'll not get into, but the hope has been if we give them explanation, we'll be able to help them make more informed decisions. And there's another group in this kind of use case is the loan applicants, right? They're not directly interacting with the system, but their life can be impacted. And they may want explanation if their loan get rejected to be able to seek recourse, improve future chance, as well as to contest the AI. There can also be business owner who may want explanation to assess the suitability of AI for their particular use case, and also regulatory body who want explanation to be able to audit for legal, ethical compliance, whether it's bias, privacy, security. So whenever we want to make this kind of a top-down characterization, right, this granularity, level of abstraction is the key question, right? How do we make actionable enough recommendation? Right, so recent work, for example, this work came out of MIT by Suresh et al. They proposed that the persona is not granular enough, right? For example, a decision maker at different usage points may want different explanation because they have different goals, right? When they're introduced to a system, right, they want to assess the compliance. When they work on a particular case, they may want to take better actions, right? So they suggest to consider user goals. And this also very much aligns with social science literature of this kind of functional position or goal-oriented position, right? Understanding is a means to an end. We cannot really talk about is the understanding good enough without considering what's the end goal. And in my own work, I tend to find that even this goal is not granular enough, right? On the other hand, there has been HCI literature, social science literature showing that people's precise explanatory goal can be expressed by what kind of questions they ask, right? A why question, a what if question, a why not question will need different kinds of explanation, right? Taking this, debugging a model as a task goal, right? People may ask, what's the performance? Is it good enough? How does the model make decision? And why the model make a particular kind of mistake, right? So this paints a rather nuanced picture that people's explainability needs vary a lot, right? Depending on the question, depending on their goal, knowledge. So having top-down characterization is useful. At the end of the day, we also need bottom-up, user-centered approach to understand for a particular application, for a particular interaction, what kind of needs people have. So that has been my own work, the focus of my own work for a couple of years. We wanted to develop a user-centered design process, starting from understanding people's explainability needs and use that to drive technical and design choice. So I'm going to give a very high-level overview today. You may have noticed I always have the reference at the bottom if you're interested in checking the detail. So where we started was, again, in 2019, I was working on this XAI toolkit, and I got very interested in this question of, we're now putting out this toolkit. Do we even know what practitioners need? What kind of explanation they need to incorporate in their AI application? So I want to understand this design space. To do that, we decided to interview designers working on different applications who are also this kind of bridging role, understand their users. And this kind of question-oriented view was very helpful, right? Because we're doing a little bit more forward-looking. Practitioners are not necessarily using this algorithm yet. So instead of getting into different algorithms, we simply try to understand what kind of questions their users have. So we asked them in this open-ended fashion. We also prepared this pre-populated question cards, also grounded in what are some common questions that current techniques can answer. And then with that paper, we try to make two kinds of contribution. One is that we look at what kind of question emerge, why they emerge in real-world context, and try to make a relatively high-level design recommendation of how to address these questions. We also did a gap analysis, right, looking at what kind of questions people tend to ask, but current technique do not answer well, and make a recommendation for what kind of future methods may be needed. Another contribution we made was this XAI question bank, right? So we quote-unquote designer-sourced people's common question, and we did content analysis, we clustered them, so we have this set of more than 50 questions that happening across different AI applications that represent this kind of common space of people's explainability needs. And they're also clustered into this 9 different categories from data, output, performance, how at a global level, why question, as well as multiple counterfactual questions. Then the follow-up work we did is we took these 9 categories of questions, then we mapped them to XAI techniques that can answer them. The nice thing about questions also, they're granular enough. You can map them to specific algorithm, and we particularly focus on ones that are already available in open source toolkits because we want practitioners to use them. And by doing that, we also arrive this recommendation in the middle about what kind of explanation can answer those questions and also grounded in technical feasibilities. Yes, Michael?
Yeah, this is really interesting. I'm curious. You've mapped from question to technique, and you talked about gaps. I want to ask you about a different kind of gap. So let's say we have these sets of techniques that are trying to address each question, between, how do we know how closely they actually address the uncertainties in those questions? Like, have we crossed those gaps, or are we?
So my answer is in the next slide.
Oh, yes.
And yeah, so before my next slide, I want to call out there two core ideas, right? One is we're using question as a way to reframe the technical space. Rather than think about, is it feature importance, counterfactual, we want to reframe it as what kind of user questions this algorithm address. And that also encourage practitioner to foreground understanding user needs rather than technical feasibility. And another idea is we want to turn question as a boundary objects to support designers and data scientists to work together to find the right technique and fill the gaps that Michael was asking, right? Because designers look at table, they understand what kind of question people ask, what's the underlying needs. And data scientists look at it. There's also URL to the code library. They can look at the technical details, so they can make a decision together. So then we propose this question-driven XAI design process, which has 4 steps. The first step is you want to identify your user question, and this can really be just a lightweighted exercise in your user research. Introduce the AI system, get people's reaction, and followed by asking what kind of questions you have. Right? You want to gather the question, analyze the question, identify priorities. For example, what questions many people ask. And the third step is where the designer and data scientist needs to sit down together, find the right solution. They can use that table as a reference, but importantly, they have to consider their user, their model, their data. Right? With that, data scientists can implement those techniques, and designer can create a design based on the technique they chose. And we emphasize it must also be an iterative process. So while I was at IBM, we did a lot of work really trying to encourage product teams to adopt this process, right? So one example here is, so this is a collaboration with Watson Health. They're developing this healthcare adverse event prediction system, meaning a doctor doing like a discharge, this system can tell them this patient have a high risk of unplanned hospitalization and they need to design the care plan accordingly. So we started with the process of interviewing doctor, gathering their question. For example, everyone asked the why question, why this patient have this high risk. Also, lots of doctors kind of somewhat surprisingly are interested in the data because they want to know if the data aligns with their patient population. And you can see the design we created on the right has a clear correspondence with the questions we collected. So that's a very high-level overview. I do want to move to the second part of my talk, which is something I'm more excited these days, but I want to warn you, things are going to take a downturn from here. So I want to move to the second type of contribution, is that human-centered approaches, empirical studies can help us uncover pitfalls, right? So there has been a lot of excitement, right, including system work, incorporating those algorithms. But today, I want to draw your attention to some hidden risks of XAI methods that are discovered by empirical studies. And I want to particularly focus on this use case of decision support. The general setup of AI decision support is human make a decision for a case, but now we're introducing a model into the middle. The model is making a prediction. And that essentially turned as a human decision maker's task into a reliance decision, right? Do you take the model prediction, rely on it, or you do something else? And whether this reliance is appropriate, depending on whether the model prediction is appropriate. So there has also been the hope that explanation can help. If you add explanation together with the prediction, then people can gain more insights about the model decision. Then that helps them to have more appropriate reliance and ultimately better decision outcome. But the reality is quite the opposite, right? So we had this paper published at FACT 2020 together with my former colleague Yunfeng Zhang and Rachel Bellamy. So we did this controlled experiment where we use this kind of a semi-toy decision task where we give you someone's profile and ask you to judge if this person belongs to a high or low income group. And then we use this very basic feature importance explanation, tells you for this profile, which feature indicate is a high income, which feature indicate a low income, and that's how overall I think this person belongs to a high income group. Well, we find that showing explanation versus not showing explanation, just showing the prediction actually reduce the decision performance. And the reason is when the model is uncertain or when even the model is wrong, showing explanation actually increase people's tendency to blindly follow the model. So that's what's called over-reliance. And we're not the only one finding this problem. There has been follow-up work also not just in this kind of decision support use case, right? So for example, my MSR colleague with the former intern Carl et al., they look at this kind of debugging use case. Data scientists use this kind of visualization, XAI visualization. They also find evidence that this leads to overconfidence that the model is ready for deployment. Some studies even find that placebic explanation without actually giving you useful information about the model can increase trust. So I want to call out that over-reliance on AI is a serious problem. It's not just this one-off errors, right? That can lead to many downstream harms as well, and long-term issues such as descaling, and also problem like how do we assign blame, how do we assign accountability, right? So that's a concerning pitfall. So many recent work try to explain this phenomenon, why we have this pitfall. Mainly from this aspect of lacking cognitive engagement, that people did not really carefully examine or reason about explanation, right? Either because they have trouble understanding it, or they're not motivated enough to do so. And this is not really because participants didn't care about the task, right? For example, Halina's paper, hi Halina, shows that people may consciously choose not to engage with explanation if they perceive the cognitive cost, the cognitive burden is too high and does not really justify the benefit of engaging with explanation. So this kind of interpretation is largely based on this kind of a dual cognitive process, right? So you may have read the book Thinking Fast and Slow. That when human process information, we follow two kinds of system. There is this system 2, slow thinking, that you try to gather information, try to make a rational judgment. But people often also resort to this system 1, fast thinking, by invoking cognitive heuristic or rule of thumb from their experience, right? So this point to a blind spot in XAI work that we seem to make this underlying assumption that there are only ideal users who will carefully engage with explanation and able to understand it. But in reality, people are actually more likely to resort to this system 1 thinking. And in some of our work, we find evidence that people tend to have positive heuristics associated with explanation. I think this kind of overall framing of explainable AI is such a good thing is also adding to that, right? We find that people tend to superficially associate being explainable to being trustworthy, being capable, and that leads to over-optimistic and over-reliance as well. So including myself, I have been using this kind of framing to explain this over-reliance phenomenon. But at the back of my head, I always have this little bit discomfort of lacking cognitive engagement. Are we blaming the user, right? Is it actually inherent limit to what an XAI method can do? So I think it would be helpful to get a bit more principled understanding of what are people doing with explanation. I'm going to borrow some concept and terminology from this work coming out of Chen Haotan's lab at University of Chicago, who is also my long-term collaborator, and the lead author is PhD student Cha-Cha Chen. So it's a theoretical paper that they differentiate model decision boundary, which is how the model make decision, how the model assign label, and task decision boundary, which is how the decision should be made. What matters is that humans have certain intuition about task decision boundary, right? Someone who are highly educated tend to make more income, right? So explanation itself, at least this kind of feature importance explanation, can only give you information about the model decision boundary. But when you are using it, you are constantly comparing that to your own intuition about the task decision boundary. And the contrast is where you can detect model errors. And I would go a step further in arguing that this kind of contrast between model decision boundary and your intuition happens to almost all these different use cases we talk about, right? And it makes a difference whether you take the position, is the human know more than AI? If you assume human knows more than AI, these are the kind of human oversight use case. You want to detect bugs, you want to detect compliance issue or context model through explanation. If you assume the AI knows more than the human, that's the kind of AI insight use case. You want to gain domain knowledge or scientific discovery from explanation. But the interesting thing is, where do we fit decision support, right? There seems to be an inherent tension here that when we talk about AI decision support, we want humans to learn something new to make better decisions, but we also want humans to have this oversight to be able to override AI. So what is exactly happening here, and what is this interplay between human intuition and AI output? So to answer that question, last summer we did this project with our intern Valerie Chen, who is a PhD student at CMU. It's also a joint project with Jane Waldman-Vaughn and Gagan Benso. So we did an experiment to look at this decision-making process. Again, we used a fairly simple decision task. One is, again, this income guessing kind of task. Another is we give you someone's online biography and you guess someone's profession. So one is a tabular data and the other is a text data, right? So there's nothing new about the task. They have been used by prior HCI studies because these are accessible tasks, and honestly also the training data is easy to get. But what we did differently is we went to this good old psychology HCI method. We asked people to think aloud. Then we look at their think aloud data, the traits, to understand what is exactly going on in the decision-making process. We also wanted to look beyond this kind of feature importance explanation and another categories of explanation called example-based, right? There are different forms of example-based explanation, but we did something very simple. We just show people similar instance using nearest neighbor to find a similar instance. We show people the model's prediction as well as the ground truth. So you may argue this is not really about a model decision process if you adopt this very narrow definition explanation, but the argument has been that they give people idea the model's decision boundary, and I would argue they also give information about the task boundary because the ground truth, right? So what we find is, again, feature-based explanation, very consistent with the other work we talk about, is they led to over-reliance. So when the model is wrong, it actually decreased people's performance accuracy. And overall, we did not see human-AI joint decision overperform AI alone or human alone. But when we look at example-based explanation, right, we find that they did not have this over-reliance problem. They increase people's performance when the model is right. And overall, we observe this complementary performance, that this joint outcome overperform human or AI alone. You will be surprised, it's actually pretty rare in this kind of a study to observe this complementary performance. So what matters is we want to understand what exactly happening, right? Part of our frustration is there has been lots of work on human-AI reliance or trust, but we actually don't know how this appropriate reliance, human override AI, actually happen. So we look at this think aloud data, right? We summarize this three we call pathway for people to override AI. The first one is when the human already have a strong intuition about a decision outcome, and the outcome is different from AI prediction. The interesting thing is we observe when people have a strong intuition, they actually less likely to engage carefully with the explanation. And also coming back to the question of is decision support about human oversight or AI insight? And I think that's actually both, and it really is a case-by-case basis. And I also point to like this kind of decision support. We need to consider different needs at a case level. And the pathway two is quite similar to that Chen et al.'s paper, is people apply intuition about the features to reason about negative evidence in explanation, whether they disagree with how the model weighs, or they disagree whether that is actually similar how the instance should go. There's also a third path, is people try to recognize AI limitation. Whether it's at a global level, they think, oh, AI is not good at this kind of case because biases, or they try to recognize for this decision, it's an ambivalent decision, they should not rely on it. Now let's look at the two explanations, right, how they make a difference. Very interesting, we find that when people are given this feature-based explanation, they are much more likely to acknowledge they don't know, they don't have a strong intuition. One of the reasons is this actually visually quite overwhelming, right? It's overlaid on the instance where it's a visualization. They disrupt people's natural intuition process. While with example-based, people can just focus on the case itself before moving on to other information. Another reason is if we look at the second pathway, we find that people actually have a lot of difficulty to reason about explanation. One main issue is that human intuition tends to be qualitative. We may recognize, oh, this is a relevant feature, this is relevant keywords, but we may not know like this word should be 2 shades darker than the other word, or this feature should be 20% more. And when people are confronted with that and kind of quantified information, they tend to feel confused, and many of them choose to acknowledge they don't know and delegate to AI. The interesting thing with example-based here is also, it actually has this benefit allowing people to form new intuition. For example, they look at example, they say, oh, professors tend to publish at this kind of journal, so they have this new intuition about feature through this kind of inductive reasoning, because example bringing additional context. And if you look at path 3, it's also interesting is people try to, from explanation, also try to recognize this unreliability signal through a certain kind of pattern, right? For example-based, it's very obvious. That is when the model makes mistake on similar instance. They tend to actually correlate with error, especially when the model make a mistake on both example. But the nice thing is it's a very strong signal. People really gravitate towards that. In contrast, feature-based, in theory, right, they have a signal that is, if the model sees feature importance going both sides, that is a very ambivalent decision. But people don't recognize that. Only very few participants recognize that as a signal. So I think that kind of, go ahead.
Oh, yeah, sorry, I haven't been able to read Valerie's paper yet. I'm curious, because I like something that you said, which is like feature-based explanations seem to be more like quantitative, whereas like example-based are more qualitative, like you're trying to figure out what the patterns are. Do you know, like, because I think maybe, like in my head, maybe the quantitative elements could be more useful for like generalizability. Maybe that's why we try to give it to people. Like, this is a formula that you can follow to like predict the future, like predictions that an AI would make. Do you know whether like if there's a difference between these two and like how people are able to then predict or project like the AI's abilities like in the future?
Right. Yeah, that's a good question. So this is not to deny like feature importance is not useful at all, right? I think they're, at least for some kind of user, they might not be compatible with how people reason, but I also think there is a space for design solution to make that more compatible, right? You can imagine one way is we don't start with showing you super quantified, super detailed information. We can tell you what are the top features. If you want to dig deeper, you can choose to look at it. So that's just one example. But I think the lesson is there's certain incompatibility, and we need to kind of bridge that part of gap. So yeah, so I think the results kind of really resonates with some reflection we had in that book chapter about this root cause of this XAI pitfall, right? Which can be, again, broadly applied to AI, that we put out some AI technology, then they have this kind of a hidden risk, right? One reason is that the output may disconnect with people's cognitive process, right? We don't consider due cognitive process. We don't realize this feature importance is actually incompatible with how people reason. But I think there's a deeper issue here, is that algorithm development do not take into account this diverse downstream usage context, right? This is not to blame individual individual researchers, right? When they don't have this established practice or scaffold, when AI researchers develop algorithm, they may think about use case that they themselves are familiar with, such as debugging, instead of what the other use cases we talk about, like decision support, auditing biases, right? So that need to kind of blind spot of important criteria that people care in different downstream use cases that are not going into this technology development, right? For example, people care about detecting errors. Why aren't we optimizing or at least evaluating with that, right? So with that reflection, I want to move to the third part, is how HCI approaches can expand the toolbox. For that question, today I want to plug some of our most recent work, which I also think is our effort to fill these two sets of disconnect. One line of work I'm excited about is to make explanation more human compatible by drawing inspiration from human communication, where I think the primary contribution are frameworks or ways to rethink how we have explanation rather than algorithm per se. So broadly, right, there has been criticism around the fact that current AI explanation have significant gaps with how human explain. And the best place to read about it is this Tim Miller's paper, where he did this very nice overview survey of social science literature, getting into what are some fundamental properties of human explanation. Today, I want to focus on the bottom two, which is human explanations are selective. And when being selective, we're also tailoring to the recipients, right? What do I mean by selective, right? Taking an example, there is a car accident. And usually there can be dozens of events leading to that accident. But when you explain, you're not going to talk about everything. You're going to be selective. And social science literature showing that this selection is not arbitrary. There are common heuristics we follow, and that also depend on what kind of goals we have, right? If someone is interested in this fact of the damage is surprising, then you're going to pick courses that are most relevant to that, that the speed is very high. If you talk to a police who wants to diagnose the courses, the problem, you're likely to pick what's the most abnormal event, like this car made a sudden lane change. If you want to give a lesson to your kid, you may pick what's the most changeable that really should not have happened, that the driver is drunk, right? So we want to mimic this kind of selectivity of human explanation. So this is joint work with Chen-Hao Tan, and lead authors are Vivian Lai, Yiming Zhang, and Cha-Cha Chen. So we propose this general framework to produce selective explanation. And it's to augment existing explanation. So take any kind of feature importance explanation, rather than showing you all the feature information, we want to select ones that you would believe to be relevant, abnormal, or changeable, depending on the selective goal, right? And how do we get there is we want to learn about your belief of relevance, abnormal, or changeability by your input, your annotation on a small sample. In this work, we propose also different ways to get that kind of input, but I want to walk you through just an instantiation, right? So this is a task that the model is doing this sentiment judgment of movie review. And then you have this kind of feature-based explanation you can generate from any kind of feature importance algorithm that tell you the model thinks this is a positive movie because it picked up these positive keywords. One is that it's still visually overwhelming. And I would also say it's disruptive. You might end up get hung up on some relatively trivial thing, like why the model picks up Western as a positive indicator. So we want to generate selective explanation by learning your belief of what is relevant to movie sentiment task. We can do that by critique-based feedback. We show you example, we show you model explanation, and you can tell me which one you think is relevant or irrelevant to movie sentiment. What we can get from open-ended feedback, we give you sample, you tell us which keywords you consider as relevant. And we just do with a small sample, say 10 movie review, then we train a prediction model to predict in unseen new instance which keywords align with your relevance belief.
Is this model tailored per individual, or are you running a single model across people?
Good question. So in that general framework, we do consider there are different ways to get this input. You can get at individual level. You can get a group of similar users to annotate it. So both are fine. We actually did 2 sets of experiments, one with your own input, one with similar input. That's the details in the paper. Yeah. And then we use that to augment the explanation, right? So we take this raw explanation, we predict whether the words align with your relevance belief. If it does not align, we gray out the words. So we're essentially saying, this is what the model picked up, but these words, you're going to think them irrelevant anyway, so don't look at them. Just look at, see, the model picked up the keywords pretty good. So then we did a controlled experiment. We compared this experiment condition with selective explanation and the raw explanation, the unselected one. And we find several benefits. So the first 2 are more related to people's subjective perception. We find that they improve people's subjective understanding because the selective explanation is sparser, they're clearer, they're easier to understand, so people feel they understand better. And the second one, interesting, we also find that improve people's perceived useness of the AI. But back to Michael's question, we only find that in a condition when people provide their own input. So that really attributes to, the reason is because now I can, my own input augment AI output, and I end up liking the AI better, which I find interesting. The last one I think is most promising. We also find selective explanation improve decision performance and reduce over-reliance. So let's look at one example, right? So this is an example where the model made a mistake. The ground truth is a positive review, but the AI think is negative. If you look at the original explanation, right, the reason is the model picked up some questionable negative word, right? It thinks stop words and also the word depriving to be indicator of negative sentiment, which is questionable. That's true for movie sentiment judgment. But once the selective explanation is in, those questionable words are grayed out. And what's left is actually more consistent with the ground truth, though the strongest word is the greatest. I want to point out here that this is because the gray out can be seen as a form, this contrast we talk about, right? This contrast of what the model think the decision boundary, what the model think is relevant, and this human intuition, what the human think is irrelevant. And I want to emphasize that this work because in this task, sentiment judgment, human can provide reasonably good intuition so that this gray out provide reasonably good signal of model error. And in fact, if we look at the percentage of highlights, we can see that with a selective explanation, the highlights is actually more aligned with the ground truth. They increase the percentage that align with the ground truth. So now people look at selective explanation. If they pay attention to the highlights, they're actually more likely to get it right rather than following the AI prediction. So that explains this. We observe this improved performance. So those are some promising results. I hope that pique your interest to read the paper. I'd love to hear your feedback. I also hope this study kind of showcased the opportunity as well as interesting nuances when you try to operationalize the kind of human communication behavior into computational interaction. I have a few minutes. I want to spend a few minutes briefly touch on this work. So this is a line work I'm excited about, coming back to this second disconnect of downstream use case when AI researchers develop algorithms, right? I think one place to close that gap is to bring more insights, bring more consideration of this downstream use case. I call it usage-informed evaluation, and I also think this is where HCI research can make valuable contribution by bringing our understanding of downstream use case. So we have this paper published at HCOM end of last year. So we proposed this concept of contextualized evaluation. So we're motivated by this observation of a gap that in the AI community, there has been dozens of evaluation criteria or construct proposed, right? You can use them either for user study evaluation or developing computational metrics. For example, lots of work trying to quantify the explanation faithfulness, compactness, robustness, and things like that. But on the other side, right, as I discussed in the beginning, HCI work trying to point out that there are different downstream use cases. People have different goals they want to achieve with the explanation. So our goal is to be able to explicitly consider this context dependency, right? In what kind of use case, which evaluation criteria matter? So I think this kind of thinking can be broadly applied to whenever we develop AI technology has diverse downstream use case, right? What's in my mind these days is focuses kind of a quote-unquote general purpose large model, right? I think this has some similarity with the recent evaluation work come out of Stanford that when you evaluate large language model, you want to first articulate the scenario and that guide your choice of evaluation metrics. But what matters here is also, I think, empirical study can help us really to get to that context dependency. And this helps with responsible research, right? Help AI researcher articulate which downstream use case this explanation is good for, and also help practitioners, right? When they work on a particular use case, they know what to evaluate, what to choose for. So I think what matters is this kind of a high-level idea. The methodology is actually pretty straightforward. I would say a little oversimplified. We use this kind of scenario-based survey. We recruit both XAI experts and also crowd worker as this target user of an application. Then we show people scenario. This is an AI application, and this is a scenario of you are using explanation to achieve a certain goal. And we develop this scenario by surveying HCI literature, looking at those taxonomy of use case, taxonomy of user goals. And we just ask participants, in this scenario, how do you rate the importance of different evaluation criteria? So the details are in the paper, so we can get this kind of rank, right? How do we rank this evaluation criteria for different kinds of use case? One is they give you this nuanced understanding of what evaluation criteria matter for what use case. And you look through them also from participants' qualitative comments that give you understanding of why. And another point is also give us this critical understanding of what people care about and where are the gaps in the current practice, right? For example, again, for decision support, people care about this unreliability / uncertainty communication, but we don't have a good metric to evaluate that. So I'd like to conclude my talk with some personal lessons learned from working in this in-between space of algorithms and user experience, especially by working close to practitioners, right? One is I think it's useful to have this kind of human-centered reframing of technical space, right? To be able to articulate for a technique what kind of downstream use case they serve, what user needs, what user values they serve. And it was also helpful to develop means to help AI researchers to articulate that as well. And second is we want to facilitate responsible use of technology. I think especially with AI, sometimes the research advancement is detached from specific use case, and we need to carefully examine what are the pitfalls, what are limitations, what are the mismatch of assumption that will also help practitioners to develop technology in a more responsible way. And third one is, it may sound obvious that I think HCI contribution is also about expand the practitioner's toolbox with design tool. I think the issue is sometimes when people talk about AI, they mix the model and application, but there's a whole design space that a lot of things can happen that that practitioner can really take advantage of. And lastly, I think is as HCI researchers, I think we have a responsibility to engage with deployment context and people's lived experience and bring that back into technology development. And criticism is not enough. It's also about how we formalize, operationalize human needs as computational or evaluation framework. And with that, I want to thank you for your attention. I want to thank my human-XAI community, and I'm happy to take questions.
All right, we've got a few minutes if folks want to engage.
Hi. I was curious about your experiment where you had explainable examples instead of using the feature-based.
Mm-hmm.
Is that in terms of you're trying to do it for each model, then they would do it, or is that for every time the AI makes a prediction? Because I'm curious about the time that it would take for them to read through all of the examples, and if you're, say, doing content moderation or something like that, where you have tons, is it feasible, or do you expect them to be able to do those the examples each time?
Yeah, that's a great question. I think there are two separate things. One is I want to clarify, like, all the explanation we study in that experiment are local explanation. So everything is for that particular prediction, right? So that the feature for that prediction or example for that prediction. But you touch on another more important topic is this kind of calculative costs and engagement that I think there's general tension with explanation is it can be overwhelming, take additional costs again with a Helena's paper, right? So I do think part of the example-based explanation reduce costs come from some of the signals are very easy to recognize. You don't necessarily have to read the detail. You can look at whether the model makes mistake on those examples. So that is actually, I would say, a lower cost signal that help you to detect model without necessarily read the content. But you also have the choice to make deeper engagement to reason about, is this example actually close, or where this differential feature should go. So they give you this kind of choice. But that's an excellent question. Thank you.
Thank you.
I'm happy to. We can chat later, but I'm happy to ask here. One of the things that you've elicited through the project that you were describing was essentially feedback on the explanation model itself, right? Like that you're learning that the following features of explanation are not useful, but it's not just that it seemed like from the examples you were giving, it's not just that they were not useful explanations, it's that they were actually not good for the model to be paying attention to at all. So it does raise the question of why are we using that to improve the explanation rather than just to provide that as feedback for the model?
Yeah.
And like if you subtract that out of the model, then maybe the explanation would have made more sense.
Right. That's a really good question. I think we definitely struggle with the question, should it improve the explanation or should it improve the model, right? I think there are use cases you just can't improve the model. You take a black box model, then that's the only thing you can do, right? But there has also been work around using human rationale as training signal itself to improve the model. I think a reasonable follow-up work we do is probably use that as a model training signal and see whether that improves the model. I think that's definitely something we should do. But that's an excellent point. I don't have a clear answer like which way will go better. But there are situations we just have to use it to augment explanation.
I mean, if I were to push back on myself, one argument you could give is that the thing that would make me better at making decisions does not necessarily make me a better teacher. Yeah. Right? If I'm trying to explain something, that doesn't mean like how I do and how I explain might be totally different skills.
Yeah.
Okay. The other question which is you're probably expecting, but just sort of given recent movement, where does all this sit relative to generative models, right? Like where are we, where we ought to go? You know, this was mostly focused on discriminative models and things where there's explicit features and so on.
Yeah, thanks for that question. And I actually have a slide I didn't have time to touch on today, but I can talk more. So I think, again, there's a human-centered perspective. One important is we have to consider end goal. We cannot talk about explanation without articulating what's the end goal, right? So I think with this large general purpose model, it's become even harder to articulate. We don't even know what are the different use cases. So I think explanation will be useful, but we need to look broader than algorithmic explanation. We need to think in terms of transparency, right? For example, one use case that I didn't have time to touch on today, we have this 2 Kai paper coming out, actually a collaboration with Harry here. So I'm very interested in this space of this question of responsible use, right? You have this general purpose. Where should I use it, especially for designers, right? And in this kind of use case, I don't necessarily think the answer lies in algorithmic explanation. Tell me with this input how I got that output, right? What I'm interested is, what is this design material? What is the boundary, right? What's the capability and where things break? So in that kind of use case, I think this concept of model interrogation you mentioned in the beginning is more useful. You want to give people a tool to help them to see where things might break. And that will be more useful than explanation. So that's just an example. I feel like we need to look beyond algorithmic explanation and think about what's the end goal people want to achieve. And we need to have this broad set of how do we help people understand them better. That's my answer. Thank you.
So going back to that example where there's kind of the loop between people getting the explanations and then kind of critiquing which parts are useful and then that informing future explanations, I'm curious about how that could be done for problems where people have a harder time making those decisions. So for like positive or negative movie reviews, that's something that like that's a human task that's like easy to do.
Yep.
But sometimes we're using models for things that are like not easy to do for people.
Yeah.
Are there ways to still extract the insights from people about like what sort of explanations are useful even for those kind of more opaque tasks?
Yeah, that's a great question. And it really gets to this, I think, a fundamental problem when we study human AI decision making, that we're mixing different kinds of decision support, right? Like a movie sentiment review, then human has certain knowledge, but you can also have a domain that human actually want to gain insight from the AI, right? So again, I think a lot of benefit we see in that experiment comes from because that task human can give reasonably good intuition, right? So that may not generalize to the other kinds of tasks. But in our framework, we did propose that in that kind of task, maybe it's more useful to get input from domain experts. You get that from domain expert once, and then you propagate that. And that may help people who are not domain experts to make better decisions.
Gotcha.
Thanks for the question.
You landed that exactly on time. Usually we hit 12:30. So let's thank our speaker.